Sample 7. The total head loss from A to E as shown in the figure is 20 meters. Using friction factor of 0.02 for all pipes, find the discharge in pipe 2, the discharge in pipe 1, the discharge in pipe 4. So this is the given figure. So the total head loss from A to E is known. So it is equal to HF1 plus HF2 plus HF5. Then we can compute HF1 and HF5 in terms of Q, which is Q equals Q1, which is equal to Q5. Then after that, we have Q equals Q2 plus Q3. Then HF2 in terms of Q2. And take note that HF2 equals HF3 plus HF4. Then from there, we can relate the discharges of 3 and 4. Q3 equals Q4, remember. So HF2 equals HF3 plus HF4, then we can express Q3 in terms of Q2. Then from Q equals Q2 plus Q3, then Q2 now is in terms of Q. Then knowing that Q is in terms of Q, as well as Q1 and Q5, Q5 is Q, Q1 is Q, Q2 in terms of Q, then we can compute Q from this equation here because this is 20. Then after that, everything can be determined. So HF1 is plus HF5 because they have common values 0.0826, friction factor 0.02. They have the same discharge, so Q square, I call it Q square. The diameter is also common, diameter 1 and diameter 5 is 0.6 to the fifth. Then what is not common would be the length. So L1 is 500, L5 is 650. So this factor times 500 is HF1. This factor times 650 is HF5. So HF1 plus HF5 in terms of Q square is equal to 24.43 Q square. Let's express HF2 in terms of Q2. HF2 is 0.0826, 0.02, length 600, Q2 square over 0.5 raised to 5. So that means HF2 is equal to 31.72 of Q2 square. Then as I said, Q equals Q2 plus Q3. Then HF2 equals HF3 plus HF4. And Q3 equals Q4. Take note of that. So in this equation here, what is common is 0.0826 and 0.02. So common for HF3 and HF4 is Q3 because Q3 equals Q4. So we will not write 0.0826 and 0.02 anymore because they will be cancelled. So beginning with HF2, length Q2 square over 0.5 raised to 5 equals length of pipe 3 400, length of pipe 4 450, diameter is also common, 0.45 raised to 5, then Q3 square. So supposedly 400 length of pipe 3 Q3 square over diameter of pipe 3 to the fifth plus length of pipe 4 Q4 square, but Q4 square is also Q3 square over diameter of pipe 4, so common. So we can now express Q3 in terms of Q2. Q3 is 0.6456 of Q2. Then substitute into this equation, Q equals Q2 plus 0.6456 of Q2. So that means Q2 in terms of Q is 0.6077 of Q. Substitute here for HF2, 31.72 of quantity 0.6077 of Q square. So HF2 is now in terms of Q square. Then substitute into this equation here, 20 equals 24.43 Q square plus HF2, 11.714 Q square. So we can now compute Q, which is equal to Q1, which is equal to Q6, 0.7439 cubic meter per second. Finally, we can now compute Q2, which is 0.6077 of 0.7439. So Q2 is equal to 0.4521 cubic meter per second. The discharge in line 1, it's already determined 0.7439. And finally, the discharge in pipe 4. Discharge in pipe 4 is also the discharge in pipe 3. So Q4 equals Q3 equals 0.6456 of Q2 of 0.4521. So Q4 is equal to 0.2919 cubic meter per second. So that's it for this problem.